Hey guys, this is Evan. Today I decided to go over a little script I wrote for modeling a reinforced concrete beam. So I work as a structural engineer, and usually I'm doing calculations which involve a lot of dimensions, a lot of units, and when I'm modeling, let's say a beam or something, sometimes it'd be nice to have somebody who would just check and see if my bars are going to fit in a certain way per code. Um, for the other civil engineers out there that know what I'm talking about, basically, this should be pretty straightforward for you. You're gonna know all these terms, but if you're not familiar with structural civil engineering, this can be a bit difficult. Additionally, as a warning to the civils out there, this is also pretty object-oriented heavy, so it's gonna be a lot of programming. This is written in Python. Um, Basically, if you don't know what a class structure is, a an object or a method versus a function is, I'd recommend you go and look up those values. So anyways, let's just jump right in. So here is really where the code begins executing for Python in the name main. And this is basically showing at a higher level what is going on. And at the beginning here, I'm defining my units. So if you guys are familiar with this approach to defining units, what you can do is you can tag your dimensions with base units. So inch would be equal to 1, pound equal to 1, which basically means when you run all of your calculations and you have all your dimensions in it, at the end everything's going to be in units of inch and pounds, unless you do an inversion like down here I'm showing. So for example, I'm inverting, I'm saying 1 over kip feet, which basically will return it in units of kip feet. So that's a nice trick if you do a lot of computational engineering and you want to avoid having to use software like MathCAD where it'll handle the units for you, but then you don't get the extensibility that you get using Python or whatever else. Anyway, so the way that this is set up, and I'll walk through these classes and how they actually become what they are, is that at first we start by instantiating a beam with dimensions. So we give it a width, a height, a length, and a cover amount. Then we assign our top steel, so we say the number of bars, the bar size, and the number of layers of bars. This is the bottom. Then we assign stirrups for shear reinforcing to the beam object, and then we have some methods here that kind of do some checks on us to see if it meets the code, and I believe it'll also provide the amount of steel that's involved. Anyways, so let's just jump right in. Now, the first class I have here is the rebar class, and what I'm doing with this is I'm using it to maintain data regarding the individual bars, which I think it'd be good to see where that gets used. So if we open up the RCBeam class, we take a look in here. The rebar class gets called, let's see if we can find a spot where it gets called. Like for example here, when I'm asking what's the area of shear reinforcement. So shear reinforcement has a rebar object in it, and that bar has an area associated with it. And this is how it's retrieving that. So for each bar, we have the bar type. So given a certain diameter, bar size, it'll return the amount of area that it has, and then when it's initialized, it's running this. So when I'm instantiating a rebar, so example, let's say we go to stirrups here, say rebar, so here I'm instantiating a rebar object to the stirrups, and I'm giving it a size which is getting passed to it from the constructor function here. So here I have the number of legs, the size, and the spacing coming in, getting defined, and here's the rebar object getting defined. So what that does is basically it handles all the calculation for the area of steel for you. A sub s is basically longitudinal steel, and it's like a more complicated version of the Sturbs class here. Again, making use of the rebar class to define the bar areas and the size, and as well as a bunch of other information. So when I am calling the a sub s, see if I do it down here, down here, okay. Okay. I know I do somewhere, I just can't remember at the moment. Oh, here we go, yeah. So when I run this function assign top steel, I'm instantiating a new a sub s, and it's going to take the total count, the size, and the number of layers, and then it'll run a check spacing function or method on it, which I'll get to in a little bit. So here's the check spacing method. This is basically bringing in some definitions that have already been defined within the class into some variables. So for example, we have like diameter, we have total number, cover, and stirrup diameter, which is important when checking spacing because it influences the width. And then here I have the spacing check, which this is just like a little expression that will check to make sure that the resulting spacing works. And then here I have the minimum spacing assigned. I'm saying, if the minimum spacing is greater than the spacing, then the min spacing criteria is not met. Alright, next we have a method that finds the row, which is the area of steel to the area of concrete. And here you can see we're grabbing this rebar object, and then we're also grabbing the RCBeam. So what's interesting here, what I'm doing is basically I'm bringing in this object, and that seems kind of like confusing at first, but it makes sense. So let's find where this is getting called. This is getting called let's see. Well, you know what? Okay, I can't find it at the moment, but pretty sure that's what it's doing. If I find it in a second, I'll mention where it's getting used. So that RC. Oh yeah. That's right. So it's when a sub s gets defined, and that happens over here. So see, I'm literally just passing self to it. So this is interesting. So see, I'm assigning a self.property, and then I'm assigning it an object that I'm instantiating from the a sub s class, but the class itself is taking self as an argument, so it has access to the RCBeam's information. Again, it mentions this in my earlier videos, but basically these are class properties. I put them at the top. You're not really supposed to, because they're supposed to be same properties across all objects, but obviously that's not always going to be the case. And I just do this to basically make it easier to know what, since I'm not using it, I just use it to know what properties are associated with each class. Okay, next is the get layer location. So this basically computes the D value of the steel. So you tell the layer number, and it will tell you where it's located from the top of, I believe it's from the top or the bottom, depends on if you're smart enough to know if you're looking at top steel or bottom steel. Then compute D, which given it basically reuses this get layer location and is what is used to compute D. So I'm summing up I'm taking the average of the layers. That's what I'm doing. So that's why I made this function, was so that way I could write the code for this easier. So really this is just a helper function helper method, sorry, for compute D. Okay, so that's the ASP class. Now moving on to the RCBeam class. This is the class that kind of ties everything together. You could think of it as the controller and the model view controller. It's also the model in some sense, but a lot of it, I have it split up. I kind of split the model into individual pieces. On instantiation, I think as I showed below here, here's where it's getting instantiated. I pass it the dimensions. I assign the cover. I give it some stirrups. So I guess I didn't set this up as a property you could define up here. Kind of hard coding it in here, probably because I was still in the middle of writing the code for how what the stirrups would do and what the functionality would be. And here, assign cover is basically just loading this into the cover property. When I'm assigning top steel, I also run a check spacing. So this check spacing is just run automatically when I'm defining the top and bottom steel of the beam. Assign stirrups, this, again, just assigning the steel. And get layer location. I think this is just a helper method that I wrote, which it can be useful though if you're trying to figure out where your steel is. Get D top, get D bottom, so this gets you the D distance, which is useful when you're computing the beam capacity for bending. Row top and row bottom. So what's great is that, with a few entries, all this work gets done in checking, and if you're an engineer, you know that there's a lot involved in this. You have to kind of draw it out and get the dimensions and organize it. And so it's nice to have a little Python module that kind of takes care of that for you. Here I also have some interesting methods. These are just kind of experimental methods, but what this does is just checks the weight per unit length of the RCBeam, so you can quickly get what the weight is. So for example, here I'm doing a kip per feet, saying print RCBeam, get weight per length, and units of kip per foot. The HKM is the density of concrete, which is 150 pounds per cubic foot, and I'm returning that gamma times B times H to get the weight per length. Next here is the shear per length, and then this is another experimental one. Compute simply supported max moment self weight. So this is computing what the max moment is due to self weight. This is your classic W times L squared divided by 8. And again, I'm demonstrating how the units would get computed. So you just run your RCBeam method for computing the simply supported max moment self weight, and invert your result because our base units are inch and pounds, and we want it to be, kip feet, and that'll return the result. So there you have it, guys. That's my RCBeam model module. Hope you guys found it somewhat enlightening. It's kind of a complicated, I think, topic to do because very few people can I think code in Python and also understand how to design a reinforced concrete beam. But I'm hoping that this kind of serves as a bridge for some people that are trying to either understand a bit more how engineers use software and programming, and for engineers who are trying to understand how to apply object-oriented approaches to running their typical calculations. Like maybe you're an engineer and you've been doing a lot of MATLAB, and you're kind of looking at using a more general programming language to branch out with, and Python's definitely the language for that. So I'll be posting more videos shortly on engineering calculations, and I hope you guys can check them out. I have some other videos too regarding I think a fish tank simulator that I just did today, where I'm showing how to program it in Python and in JavaScript and going over the differences between the two. So I recommend you guys check that out as well. All right. Take care.